we're talking about is really a case of how, we've heard so much about this in the last few years about how Moore's Law, are we reaching some type of final point where we're going to finally see the curve level off? We've seen from a hardware perspective that this might actually not be the case anymore. We've got a good understanding, going back decades, from the very earliest Babbage's analytical machine in the late 17th, early 18th century to the vacuum tube and transistor era, the ENIACs, the Colossus, that really fall into some type of, World War I, World War II cryptography breaking type scenario. Then we have, all of the things that we've got, from the Apple II that Michael talked about, that many of us who have a few gray hairs remember programming on initially, to the advent of x86 over the last 25 years. What I really like is at the very end of this, it's not even just a case where we've seen Moore's Law continue to grow at the same slope. We've actually seen Moore's Law accelerate over the last 10 years with the advent of GPU. When you're able to change the math that you're doing, you're able to change the processor that it runs on, all of a sudden, you're bringing more power. Great. A bunch of software developers are like, why is this guy babbling on about this? So let's take a little bit of a context switch. How easy is it to get x86 these days versus how difficult is it to get GPU these days? As developers, those of us who manage a budget, can think to ourselves, I've got a team of 10, I've got a team of 20, maybe I'm a director who's got a team of 50. The difficulty of getting a GPU these days is so hard. The only thing that I can kind of remind me of in my personal life is as a kid, getting access to, the comic books that I was looking for, maybe something that's more applicable to someone today. If I'm a sneakerhead, hey, Nike's got a drop, I'm trying to get my hands on this thing, or how seemingly every summer we walk around and we see every lady's carrying the same bag. We're at that point where there is a very finite quantity of demand, of supply, and a very large segment of demand. How do we change this so that all of a sudden the users that we have, the users that we're trying to support, the use cases that we're trying to build can actually get that? So something that we're trying to do is we're looking at how we can break down the software development cycle. Everyone understands we've got to build, we've got to test it, we've got to put it into production. If I've got that team of 10, 20, 50, and I've got to go up to management and say, I need the budget for 25 of these GPUs so that we can just do the development. That's fine, okay. Then I need 25 more of these GPUs so that we can iteratively test this. Okay, this is starting to add up pretty fast. It's one thing to get one pair of Nikes, it's one thing to get one bag, it's one thing to get one copy of, X-Men. It's another thing that all of a sudden I've got to go out and fight for 50 of these things. Have we made $1 yet or a rupee yet on this? There's been no value generated for anyone. Instead, then we go, okay, we've got 25 of these things for the dev team, we've got 25 in tests so that we can somehow scale it. How big is production? Production 64, 256, 512. So it's a case where what you're doing just to build the product is a huge piece of what you're actually going to put into production at the end of the day, where you can finally start generating value. How do we change this situation? How do we change from a situation where we're spending a ton of time just getting this stuff, delivered for development, writing that JIRA ticket? How do I get, IT? How do I get facilities? How do I get ops to deliver what I'm looking for? How long is it going to take to actually procure this? Run this whole exact scheme again to make this happen for test. And then now I'm finally looking for the large nut of how do I get, 200 of these things, 500 of these things to actually roll the model that I want to do. One of the things, like Michael just talked about, is how do we change how we perceive different problems? These are all kind of solution problems that he's talked about. Everyone in this room understands that. The big differentiator now is we can go ahead and fractionalize these GPUs. Instead of actually having to procure 25 of them to get the whole team to be able to do this, we can fractionalize into half, into quarters, even down to tenths of GPUs. And what that radically does is change these economics. Instead of the case like Ganesh yesterday spoke about at the keynote, where companies and many startups are spending half of their revenue just on infrastructure to provide the service, we can drop that dramatically to 10 and 5% so that you can go ahead and actually be, from a business perspective, successful. With that, we can go ahead and eliminate huge portions of these problems. We can go ahead and create much faster time to delivery. Instead of something that would take, kind of 3 to 4 months for each of those build, test, deploy steps to occur, we can now go ahead and break that down into minutes. Being able to deploy the fraction of GPUs that it takes to validate the engineering stack, it takes to validate the environments that you're building, to validate the models that you're building, and then to finally roll it into full production and test it at that large scale that you're looking for. What this really does is it changes the time to market, it changes the money economics, and it makes the entire system work in a much greater fashion that delivers value for all of the different pieces that are involved. So now we can talk about diversity of understanding. Instead of trying to build one particular center of excellence, we now have the ability to scale the humans that are involved. How do we solve that, human petabyte that Michael just described? We can now bring teams to this with different priorities. Sitting here in Bangalore, we absolutely could have a team based here in India. We could have a team in Singapore. We can have a team in London, bringing different experiences. Let's say you're a financial trading operation, having different types of models that have already been built in different environments, whether you're trading equities, whether you're trading options, whether you're trading commodities. Those are all different skills, all different ideas that you're trying to bring to the table. But with that, being able to cross-pollinate those ideas across multiple teams, as opposed to having to hold on so tight, we only have 25 cards. This is the only team we can do this. We can take whether it's that 25 cards or really, in a 3-shift environment, 10 cards to be able to develop a much greater range of options. We're able to leverage the people who are working on these problems in completely different ways than we were able to do this before. So what this does, my CMO tossed this slide in there. I want to make sure that I get my sales pitch in as well. With Vultr, we have the ability to not only deploy 3 data centers, as I showed here, in India previously, in Bangalore, in Mumbai, and in Delhi. We have 27 other locations globally where we can scale up these fractional GPUs and large GPU sets when you finally do move into production. We're actually adding 2 more data centers in the next month in Tel Aviv and in Manchester. This is really a case of how do we make this a exponential growth opportunity as opposed to a linear growth opportunity? How do we take advantage of the changes in the hardware that exists today? Essentially, 2 years ago, we lived in a pre-virtualized world, a world where there was a single user, a single tenant, and now we have changed that environment to where we can have a multi-tenancy opportunity for users on GPU as well. So really a case with Vultr, the ability to quickly deploy this globally, both on a easy-to-use UI basis, a very simple API basis, supporting Terraform, supporting Ansible, supporting Jupyter playbooks, in pushing all of the most advanced ways of supporting, GPU and x86 development. This is another way of how do we leverage that instead of having to rebuild models as you're moving from one stage to another. We tested on T4, we're going into production on an A100. You can actually test on A100 today, H100 today, move from build to test to production, all on the same hardware platform. It really saves having to refactor and having to really worry about what are the different cases that we're going to lose moving from one platform to another. Just wanted to say thank you so much, everyone, for your time. Wanted to really challenge you to rethink about how you can approach all of these different scenarios and all of these different problems.